Hello teacher, my name is Kititash Lepiriyabong. Today I will demonstrate how to calculate the center of mass of a body. First, why do we need the center of mass? So, in order to calculate and study about the dynamic response or the acceleration motion of somebody, it requires center of mass or center of gravity to determine the point the force will act at that position. So, I will show you some mechanical parts and I will use this part as an example to find the center of mass. So, this part called the fixture block. So, this composite body made from the different materials. In the left side, or the yellow part, is made from the brass, and the blue side is made from aluminum. So first, let's determine and divide our blocks into 8 different parts, like this. And the first part is a semi-cylinder at this position. Next, and it's a 3 rectangular parts. 1, 2, 3. At this, the biggest one, the base one, and the small one at the front. Next, and 3 triangular parts. 1, 2, and 3. 1 is at the end from the front, and 2 and 3 at the middle of this body. Next is the 15 cm diameter hole bored through the center of the chamfer part. This is the hollow cylinder, and we bore through the chamfer part like this at the center. And next, now let's determine our dimension and the material. First, our dimension, our unit will be in the centimeter. So from the different material, they will have a different density. Like in this picture, I use it on the SolidWorks to create this picture. At this, the gold one is a brass, and the gray one is an aluminum. Brass has a density of 0.0085 kg per centimeter cube. Actually, is equal to 8,500 kg per meter cubic. But in centimeter, I need to change the unit per meter cube to per centimeter cube. And next, density of aluminum is equal to 0.0027 kg per centimeter cubic. Next thing, we need to determine the reference axis or the reference origin. If I don't specify the origin point, the XYZ coordinate of this center of mass fixture box can be anything, can be anywhere from the geometry. If I put the origin at this, I will get X bar, Y bar, Z bar at this origin will not equal to X bar, Y bar, Z bar at that origin. But the center of mass is actually at X at the same point of the body. But when we measure from this origin, it will get us some X bar, Y bar, Z bar of that origin. And if we measure from this, we will get another another x bar prime, y bar prime, and c bar prime. So here I will determine this origin as our reference origin, like this. In the picture, above picture, it acts at the left corner. If we look for the top view of this body, it will happen like this and this. And next, we need to calculate the center of mass. So we need to divide the composite body into 8 different parts, like this. This composite body is made from 8 geometry, as I show in this picture. Okay, we will talk about the center of mass or center of gravity for the geometry in this fixture block. First, the rectangle, the center of gravity will be at the center. The triangle, the center of gravity will happen as 1/3 of height and 1/3 of base. The circle one, it will appear at the center of the circle. And when we find the center of gravity for each assembly part, x bar, y bar, c bar for every part, we will use the formula to calculate the center of mass of the composite body. Is equal to the sum of the product of each body times that mass, the second body times the second mass, divide by the sum of the mass of composite body. And next, I will find the x bar, y bar, c bar for each part and tabulate the result in this table. Now, I will find the x coordinate for each assembly part first. Now, let's look at the drawing. This is the top view and this is the side view. So, our origin will be right here. And I will assume this is an x direction and this is y direction. And this is z direction. Okay, now let's figure out the x coordinate. First, I will assume the center of the for each body will happen like this. This is actually on the center of each body, but not for triangle and the semicircle. There will be a special case for this semicircle and the triangle. Okay, I will show you the x coordinate for each x bar coordinate for each assembly body. First, semicircle one, x coordinates measured from this is right here. Second one, this big rectangular right here. The hollow one right here. The bridge one is this bridge, like a nose, happen at this. Next, the base one x bar actually right here, and this one at the front right here. So you see every part the x coordinate happen at the middle, except the triangle. This triangle and this triangle, x coordinate will be 1/3 from this, maybe right here, So I can conclude that every part they have the same x bar coordinate at 50. Why 15? Because I will show you. This has a radius of 50. So 15. We measure from the center. We will have 15 from this to here. From the origin to here. From the origin to here. From the origin to here. Actually, at the same point, at the amount of 15. Okay. I will tabulate in the table 15, except this one, because it is a triangle at this, and the nose is 15 nose. Okay. Now let's determine the C coordinate because it's easier than the Y coordinate. So first one, the curved one will be right here. The rectangular one will be right here. The hollow cylinder will be right here. Okay, so the first three parts, they will have the same C coordinate because here is 30. So measure from the origin, half of it is 15. I will tabulate 15 into this, and this one. And remember, for each coordinate in the unit, it has unit of centimeter. Okay. For the fourth part, fifth part, and sixth, seventh part, the C coordinate will be 4.5. Why? Because here's the height of 9. The fourth one is the base. Right, this. The fifth one is the front of the nose. Okay. The sixth and seventh one, it is sixth one and seventh one. So it will happen at this same position and here. Let's tabulate the result into our table. 4.5, 4.5, and write this. Okay, next I will illustrate the sixth and seventh parts because it's complicated when looking at the x direction. So I will use this. Okay. The x coordinate of the, I will call this the sixth one. This is seventh one. The x coordinate of the sixth one is happen right to 1/3 of this. So this 9, 1/3 of this is 3. But when we measure from the origin point, right this. So I will need to tabulate 6 into the table. I will split into 1. It will be 6, and for the 7th one, this is the base right here. at the 1/3 of the base, so this side 9, and then along this direction is 9, 12, and then 1/3 of the height. This height is equal to 9, so 3 plus 12 plus 9. Okay. Next one, I will figure out the y coordinate. First, this geometry, and this geometry. From the semicircle, here is semicircle. From the previous presentation, we know this length is equal to 4r, and r is equal to 15 over 3 pi. But we need to measure from the origin to here. So, and this is the radius is 15. The yellow highlighted one is going to be equal to 15 minus 4 times 15 over 3 pi. Okay. Oops. Next one, the rectangular one. The CG, or center of gravity, is going to be at the center of the geometry. Measure 15, and half of 18 is 9. 15 plus 9. Okay, next, the hollow one. This hollow one is actually right here. Measure 15 because this radius 15. Okay, 15. Next, the fourth one is actually right this position at this, so we need a coordinate at this location. Measure from the origin. It will be this yellow line. Okay, first 15, 18, and how about this length? This length is equal to 60 minus 9 minus 18. We will get 33. And next, we need to divide by 2. 33 by 2, because it's the half of the rectangular. So y coordinate will be equal to 15 plus 18 plus 33 over 2. Then next, the front at the nose one, right here. Okay, let's go fast. 15, 18, 33 for the previous calculation, and half of 9, and 4.5. 15 plus 18 plus 33 plus 4.5. Okay. Okay, next is the small right triangular one. The bottom one and the above one will have the same y, same displacement from the origin. So I will calculate only one. When you see this, as I told you before, the center of gravity is happen at 1/3 of the height and the base. So this length is 9. 1/3 of 9 is 3. And it will be equal to 15 plus 18 plus 33 plus 3. 15 plus 18 plus 33 plus 3. Okay. Next, the big nose one. This one. So first, find the length of the nose. Is equal to 60 minus 18, 42. And then for this, from this picture, you know at the center of the nose is equal to 1/3 of this length. So from the previous, this is 42, and the 1/3 of 42 is 1/3 of 42. I divide into 3 sections, and 1/3 of 42 plus 18 plus 15. Measure from the origin. We will get 15 plus 18 plus 1/3 of 42. Write this. And the last one is the big nose, C direction. Okay. From C direction, you see, C direction is going upward. You measure. It is 9. I will change my color. 9, and we need another 1/3 of this height. So this height is equal to 21, because 30 minus 9, we get 21. So we will get 9 plus 1/3 of 21. So we will get 9 plus 1/3 of 21. And oops, it is the same. Okay. Next, we need to find the volume. Why we need to find the volume? Because we know the law of brass, or the density of brass, the density of aluminum. From the density formula is equal to the mass divided by the volume. We need to find mass, so we need to find the volume and then multiply with the density, and then we will get mass. And we can substitute mass into this equation, like this. Okay. For the volume, I will not explain very much because it's just a basic geometry from high school. It is the one. Volume is the area of the base times height. Area of the base is 1 pi r square. This is the circle and semicircle, and then the height. The height is 30. Second one, base times length. Area of the base times height. Area of the base is equal to 18 times 30, and the height is 30. 18, 30, and the height of 30. Okay. Second one, cylinder, pi r the radius is equal to 7.5 square. Why 7.5? Because the diameter is 15, so the radius is going to be half of the 15. Pi 7.5 square, and the height is equal to 30, because right, this is 30, this part the height is 30. And next is the area of the base times height, but this for the fourth, fifth, sixth, seventh part, the height will be 9. I will erase this first. Okay, the height will be 9, because it is only this 9. Now the area of the base is 33 times 30. Next, area of the base is 12 and 9. 12 times 9, and area of the base 1/2, height 9, and height 9. One base, height, base. 1/2, height, base. Okay. And next, 1/2, height 21, base is 42. From this geometry, 60 minus 18, 42 is going to be base. 21, 42. How about the height? The height is equal, or the depth is equal to 7 from the nose. This nose, it's going to be right, something like this, 7. Okay, and next I will use Microsoft Excel to calculate all of this number and show the result. Okay, next I will use Microsoft Excel to tabulate all the data that I've calculated and let the program calculate the data. First, just type in the value that we have found. 15, and 15. Number 6 is 6. 3 plus 6 plus 9. No. 3 plus 12 plus 9. And then 15. Okay. Now for y is equal to 15 minus 4 over 3 pi times the radius. So I need to write function like this: 15 minus, open the parentheses, 4 over pi. Write this: 4 over pi times 15 over 3 times 15, open the parentheses, 15 over 3. Now close the parentheses. and let the program calculate for the y bar. Next, 15 plus 9, 24, y arm 3, 15, 15, 15 plus 18 plus 33 divided by 2. Next, 15 plus 18 plus 33 plus 4.5. Oops. I forgot to write the equal sign. Next, 15 plus 18 plus 33 plus 3. 15 plus 33 plus 18 plus 3, and it's the same as the 7 one, and 8 is 15 plus 18 plus 1/3 of 44. 15 plus 18 plus 1/3 of 1/3 of 42. And then z is 15, 15, 15, 4.5, 4.5, 4.5, 4.5, oops, sorry, 4.5, and the 8 one is 9 plus 1/3 of 21. 9 plus 21 divided by 3. Okay, now the volume. Okay, volume is 1/2 times pi times radius square times height. Oops, I forgot to put the equal sign again. Okay, 18 times 30 times 30. Oh, again. Okay, next, pi times 7.5 times 7.5 and times 30. 30 times 33 times 9. 12 times 9 times 9. 1/2 999. 1/2 times 9. Oops, forgot again. Okay, and it's the same volume, same shape. And the last one, 1/2 21 42 7. 1/2 21 42 7. Okay, next, I don't need this. Next, the density from the last one that I just described. The first, on the left side, or the part number 1, 2, 3 is the brass one. So the density of brass in the unit of kilogram divided by centimeter cube is equal to 0.0085. And the second one is the same, but this one is special because this is hollow one, and the volume, it need to be minus. Why minus? Oops, minus. Why minus? Because it's a hollow one. It's drill through. There's nothing in there. It's just a hole. So the volume is need to be subtract out of the whole body, the whole volume. And there's nothing in there. The density will be 0. Okay. Next, on the right side is the aluminum one. The density of aluminum is equal to 0.0027 in the units of kilogram per centimeter cube, and it is same for all for the 5th, 6th, 7th, and 8th part. Now, how about mass? Mass is equal to the product of low times V times volume. So let the program calculate the number and the product of X bar and mass. So product of X bar and mass. Oops, X bar, comma, mass, and close the parenthesis. Then drag all to the column. Next, Y, do the same thing as the X product. Select Y and comma, mass, close parenthesis. Okay, and drag along here. Do the same thing. Or C coordinate, oops, C and times mass, and do the same thing along the column. So now, then we need to find the sum of the mass and the sum of the product of mx and product of my and product of mz. So I will use command sum I will get the sum of the mass with command sum with command sum and this row or this column and this sum okay. Now to calculate the X bar, Y bar and C bar for the whole body is equal to the sum of the mx divided by the overall mass, and the special one we can find the extra one, we can find the whole volume of this body by this sum and then write this. Okay, let's talk about our goal first. Our goal is to find the center of mass, so it will be equal to the xm divided by total mass. Right, this. And y bar is equal to this one divided by mass. And C bar is equal to the sum divided by overall mass. And here you get X bar, Y bar and C bar in the unit of centimeter. And I will compare to the SolidWorks result. write this. And in the SolidWorks class, I will let the Siravat to explain about how to create the shape and how to determine the origin and find the center of mass of the whole body. Thank you.
Next step, we're gonna make a fixture block on the SolidWorks. Then we click new part, click OK. Then we choose front plane. Wait a minute. And then we click normal tool. Then we click sketch, and then we click corner rectangle. Then we draw a rectangle 1 and rectangle 2. Then we click smart dimension. I'm going to choose this dimension to be 42. We change unit in centimeter. Okay. Then this dimension is gonna be 9 centimeter. This is gonna be, let me see, 33 centimeter. Yeah. This dimension is gonna be, let me calculate it. Wait a minute. 30, yeah, 30 centimeter. Okay, and then we click finish, and we exit sketch. We go feature and extrude and boss. Yeah, we're gonna change this into 30 centimeter. Change to the mid plane. Okay, change direction, and we choose this control and this. Then we click yes. Okay, finish. And we have the boss and extrude 1. We click, and then we click sketch. Click show. Yeah. Then click front plane. Go to click sketch and we draw the line. I'm gonna draw a triangle. This point to this point and to this point. And then we drag into the initial point. Okay, and then click yes. Okay, we can have like this. And we click feature, extrude and boss. And we change the direction to 9 centimeter and click mid plane. Yeah. Okay. So we have like this, right? And we click sketch 1. Oops. Wait a minute. Okay. Sketch 1, we click this. Yeah, to show. Then we click Boss and Extrude. We click Sketch 2. Click this. Okay. This. And then we click this side. We click normal to. Then we click Sketch. Then we draw the circle. And here, what about radius? Click Smart Dimension. Gonna change the diameter into 15 centimeter. Okay. Then we use this. This is gonna be 18 centimeter. Okay. Click. Go to feature and I'm gonna cut this through. Click extrude and cut. Okay. Wait a minute. Gonna see this. Gonna drag down through and click OK. This. And next step, then we're gonna choose the fillet and chamfer. Then we click this side, yeah, and this side. Okay. Then we change diameter into 9 centimeter. And click OK. Yeah. And we gonna switch the dimension to this. Okay, and we click fillet. Click this side and this side. Okay, and then we change it into 15 centimeter and click OK. Yes, we change the dimension and we click front plane. We click normal to this. Yes, gonna get this. This is we get fixture block on a SolidWorks. So let's begin the next step. Next, we're gonna split the body into two solid body, and this one and this two. Okay. First step, we click this surface and click sketch, and we draw a line. Align this point to this point. Then we click exit, and then we gonna select this surface. Then we click sketch, click line, and this point to this point. Okay, then we click exit, and then we're gonna change the wheel. Okay, this wheel. Okay, then we click this surface. Okay, we click sketch, click line, then drag the line from this point to this point. Okay, then we click exit, and then we gonna do the last one. Click this surface, click sketch, click line, then click this point to the initial point. Okay, then we click exit. So we get the rectangle, this rectangle. Next step, we're gonna click this, click command, and search the tab for the split. Okay, click this one. Then we selected the line that we do from the previous. Okay, 4 lines. Then we'll click cut part, and then we gonna deselect this item. This is very important because if you don't deselect this consume cut body, it will delete your bodies, delete all of your bodies. Okay, so deselect it, then we click okay. We're gonna click this item and this item first, and then we click okay. So as you can see, we get the solid body for the two piece. Split 1 and split 2. This is split 1 and this is split 2. Okay, so we're gonna select the first one first. Click split 1 and we choose the material for it. We choose brass. Okay, and then we select this option menu. Then we click document property, click unit, and we're gonna change unit system into the MKS. Okay, and we click the material property. Then we're gonna change the density into the brass density is 8,587 kilogram per meter square. Okay, and we change the pattern. Click brass and then click OK. Okay, so we click the second part. We right click and then click material. We're gonna click 1060 alloy, or which they call the aluminum. Okay, then we gonna do the same things. Click option, click document property, units, and change to MKS. Click material property and change the density. The density of the aluminum is 2705. Okay, then we change to the aluminum. Okay, then we get what we want. And the last part is to change the origin. Okay, we're gonna change the wheel first. Okay, the bottom wheel. So we click sketch. We we click this surface first. Okay, then we click sketch. Then we click the center line. Then we click this point to this point. Okay, and then we're gonna drag this point to this. Then we click this. Okay, so we're gonna get this style, and then we go to features and click reference geometry, and then choose the coordinate system, and we click, I'm gonna choose this point. Okay, and then okay, gonna change the direction a little bit. Wait a minute. Okay, gonna change it to this direction. Okay, then click finish. So we're gonna get what we want, and that's it. And then we can do, or we can show the center of mass by click evaluate and click mass property, and then we click this one. We click coordinate system 2 that we already provided. Okay, and then we can see that it have many property that shows about mass, volume, surface area, or the center of mass. Did you see? Okay, and that's it. That's what we want. Thank you for watching us. See you again.